Hey everyone, today we're still talking about end behaviors, and we're talking about end behaviors if you're given a function and you're able to look at the function, analyze it, and then tell me what the end behaviors are. So for example, let's say, I don't know why this is crooked, it's gonna drive me crazy, sorry. Okay, let's say that I have f of x equals, let's say 3x to the fourth plus 5. Okay, so a couple things about this graph. Well, I look at my degree, and my degree is going to tell me whether it's whether the end behaviors go in the same direction or the opposite direction. Okay, so an even degree, it's going to head in the same direction, whether it be up or down. Okay, let's color code that. There we go. Okay, so even degrees, they go in the same direction. Think about like a parabola, right? A parabola looks like this. It goes in the same direction. Okay, then the leading coefficient will tell you if it's going to open up or open down. So this leading coefficient here is positive. Okay, so I know my graph is going to open up like this. So I'm going to erase these down here. Okay, so this is positive leading coefficient. Okay, so what does that tell me? Well, that tells me the end behaviors are like drawn like this. So that means as x goes to negative infinity, what happens to y? Well, it goes to positive infinity. And as x goes to positive infinity, y goes to positive infinity. Remember, these match, okay? Notice how these y values match. Okay, because it's an even graph, let me rephrase, because the degree is even, the end behaviors will match on both sides. Okay, the y's will be the same. Okay, so when you have an even graph, when your degree is even and you have a positive leading coefficient, this is what your end behaviors will look like. Okay, so now what happens if I had changed that to a -3? So let's say this was f of x equals -3x to the fourth plus 5. Okay, well, we still know that they're going to be headed in the same direction, right? They're still going to be symmetrical at the end. The middle might not be symmetrical, but the ends will. And it will it's going to open down because of the leading coefficient. My a value is negative. That means there's a reflection in there, so it's going to flip. Okay, so this is still going to be even because of the 4 up here, but now it's a negative leading coefficient, so it's going to look like this. And what does that mean in terms of the end behaviors? Well, these are the end behaviors, right? As x goes to negative infinity, y goes to negative infinity, and as x goes to positive infinity, y goes to negative infinity. Do you see? I forgot my arrows, but there we go. Do you see how the end behaviors match again? The y's match because these match up here because it's an even graph. Okay, so now we took care of their evens. So what does odd look like? Okay, let's say I give you f of x equals, say, 4x cubed plus 1. Okay, so because it's odd, the degree is odd, it's going to go in different directions. Okay, so it'll look like this, and it'll look like this. Okay, the even ones match up, but the odd are opposite. Okay, and this is positive here, so this is going to be an odd degree and a positive leading coefficient. Okay, so it's positive. It starts down here and it goes up here. Okay, so what does that mean for our end behaviors? Let me get a different color. As x goes to negative infinity, y goes to negative infinity. And as x goes to infinity, y goes to infinity. For a positive odd graph, okay, these will match up on the lines. The x will be the same thing as the y, x, same thing as the y. Okay? So then if it's negative, so let's say I make it up here to have f of x equals, let's say, negative 4x cubed plus 1. It's going to flip. That negative flips it, right? Like we talked about. It's that a value that flips it. So they're still opposite directions. So this is odd. They're opposite directions. And it's a positive. Oh, sorry. It's a negative. If I could write, that would be really helpful. It's a negative leading coefficient. So this would be, there we go, as x goes to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to negative infinity. And if you notice, these now are opposite. Okay, so it's just some helpful tools to when you analyze this. Okay, let's do some examples now. So let me give you f of x equals 5x to the 5th plus 3x plus 2. And we're analyzing the end behaviors. So I'm just going to put end behaviors question mark. So remember, we only care about the degree and the leading coefficient. It's odd. So I know it's either going to look like this or like this. Okay? The colors match. I hope you see that. I mean, the same colors are one graph. Okay, so the direction is going to tell it's going to come from the leading coefficient. The leading coefficient is positive, so I'm going to get rid of the green graph. Okay? And this is what my end behaviors are going to look like. So if I would write that out, would be as x goes to negative infinity, y goes to negative infinity. Those match. As x goes to positive infinity, y goes to positive infinity. Okay, let's do another one. Let's do f of x equals negative 3x to the 6th plus 4x. Okay, so again, I only care about my leading coefficient and my degree. Sorry, this isn't my degree, this is my leading coefficient. It's even, so I know it's either going to look like this or like this. Even graphs match up. The ends match up. The odd ones are the opposites. Okay? And the direction is down because it's a negative leading coefficient. So I don't care about that one. I care about this. So as x goes to negative infinity, y goes to negative infinity, and as x goes to infinity, y goes to negative infinity. Those match up right there.